Welcome to this webinar. I love data visualization, but the coolest data visualizations tend to involve networks, animations, maps, and huge amounts of data, none of which is so relevant in a typical market research debrief or report. So rather than wow you with super cool visualizations, my focus today is showing you how you can quickly create meaningful, memorable, and instantly understandable visualizations, focusing on the types of data that are common in market research. As we go, please type any questions into the questions field in the GoToWebinar app, and I'll answer them at the end. I'm going to be showing you everything in Displayr as it's designed for presenting data stories, but you can of course do this in lots of other software. Much of what's been written about data visualization focuses on making visualizations that accurately reflect the data. That is, they focus on ensuring that people can get correct meaning from the visualizations. A second way of creating good visualizations is to make them memorable. That is, make them somehow visually engaging. Putting aside everything you've ever heard about chart junk, which of the two visualizations on this screen attract your attention? Yep. And there's a third way. You can focus on trying to make visualizations instantly understandable. And this is all about trying to amplify the patterns in the visualization so that they're easy to see. This infographic shows 24 techniques for improving visualizations. And they've been grouped into 3 broad categories. Today I'm going to explore a small set of the more advanced techniques and focusing a little on the techniques involved instantly understandable, as I find these are often the ones that market researchers are least familiar with and provide the easiest wins. But we'll start with a bit of glamour. The simplest way to create a memorable visualization is to create something visually striking. If it's dramatic, we can remember it. This visualization is definitely fun, but it's not good. It makes you remember octopuses with orange hair, an interesting idea, but you don't recall or really get the story that's in the data without a lot of work. This one tries to grab attention in a different way. It uses a design inspired by the subject matter. I think it's beautiful, and this makes it a bit memorable, but again, I think it's a poor visualization. When I look at it, I see stairs going down. The bottom stair seems to be broken or have carpet on or something, which confuses me a little bit. But if you read the heading, it's talking about the market growing. So the market's growing, the stairs are going down, the bottom stair's broken, confused. It's not instantly understandable. This one's a bit hard to read because it's really designed for a much bigger screen than I'm showing it on here. But it's a lot cleverer than the one we just looked at. Again, it's using a simple technique of a visual that's tied to the subject matter. But it does something a bit cleverer than that as well. The upside down column chart illustrates and resembles the flowing of blood. So the smart thing it's done is relate the pattern in the data to the subject matter. It's not just attracting attention, it's a mnemonic of sorts, that is, it aids our memory. In terms of design quality, this one of my own, is a bit paint by numbers. We've got a wallet and the color of money designed to attract or evoke the subject matter. At a deeper level, it's doing something a bit cleverer though. The core bit of this visualization is an idea we're familiar with, a drop in the ocean, a needle in a haystack, a speck of dust. It emphasizes that the initial investment is dwarfed by the monumental level of the financial outcome. Now, all the visualizations that I've just shown you require a creative spark, and that's all fine, but what do you do when you can't find that creative spark or don't have the design skills? And this is what I'm going to really focus on today, understanding the science rather than the art of creating impactful visualizations. When we look at a visualization, we give it the benefit of the doubt, but the benefit only lasts an instant. Once the instant has passed, we're bored, we move on, the chance to communicate has been lost. An artist friend of mine tells me that this is not a great work of art. It's a cartoon, but in only a matter of seconds, it talks to us. We're captivated by Michelangelo's work. We can extract meaning from it. But this, well, it looks like bricks. And I think that's why most people don't understand it. I think it's why most people don't really like modern art. They can't instinctively extract the meaning from Mondrian's work. It's too hard, so they just move on. In books on data visualization, this one's described quite commonly as the best visualization of all time, but it's not. When you look at it, what do you see? Yeah, I kind of see a big tree branch. If you study it and read books about it, it's actually a very cool Sankey diagram, but at an instinctive level, it actually doesn't work at all. We don't look to branches for meaning. There's no kind of pattern there that our brain can look on and try and decompose and understand. It's a lot more Mondrian than Michelangelo. Why can't we instinctively understand meaning? Let's do some thought experiments. I'm going to give you 5 seconds to remember what's on the next slide. Can you remember what it said? Actually, if there's a bit of a lag, maybe it was still on the screen. All right, let's try another one. Can you give you 5 seconds again? You know the drill. Even though a lot of you probably don't know who Mary Poppins is, there's a good chance that you've recalled that second word a lot better, as it's made up of words you know. Our brains find it easier to understand and thus recall things that are familiar to us. And successful visualizations actually need to tap into this level of familiarity to work. Great visualizations use shapes that we instinctively understand. Rather than show data in all its ugliness, leaving it to the brain to figure out what it means, we should instead exaggerate the patterns in visualizations to make them really clear. We want to exaggerate the shape, if at all possible. To use some jargon, we want to supernormalize the visualization. Dutch Nobel laureate Nico Tinbergen did a cruel but fascinating study. He noticed that birds tended to instinctively peck at their mother's beaks as soon as they were hatched. And so he got rid of their mothers and instead gave them a cardboard cutout to see what would happen. And the birds still pecked at it. Then he showed them a two-beaked monster, and the little baby birds still pecked at it. His fascinating finding was that they pecked more ferociously at a red rod with a white or 3 white lines on it than at a plaster model of their mother's head. Why? Because the instincts in the brain the herring gulls had evolved to having a simplified concept of what to peck at. They had this supernormal stimulus deep down their instincts of a red bar was tapping into their instinct much more strongly than a more realistic model of the head. Let's work through some examples and see what we can do with this idea. We instinctively understand intensity. We know where we can place our hand in this one and get burned. What can you see here? Yes, the small cell with the small font typhoid jumps out at us. Now people hear this and think, so tree maps with heat map shading, which is what this is, are good. No, it's not about the type of visualization. It's about the way that the color was used to communicate intensity in a way that tapped into how we've evolved to understand stimuli in the real world. You can still do a tree map with heat map shading and make it bad. This one here is using a bizarre scaling of red, gray, and green, and you just don't know what to look at. What's good, what's bad, what's interesting. Brain can't figure it out. This data shows switching between car brands. Let's look at the Ford row. It's showing us that 63 people who had owned a Ford switched and bought a BMW, 107 switched to the French brand Citroën, 64 switched to Fiat, but 4,000 stayed with Ford, a little over 4,000. So what's a good way to visualize this? Well, it turns out there's actually a special visualization designed exactly for this type of data called a chord diagram. Now, if I hover over Ford, we can quickly see that it confirms what we saw before, in some sense. Ford's a big brand, and we can see it's got bigger switching as to GM and Rover. It's a very cool interactive visualization. But if you just let your brain try and find a pattern, what does it find? It would take a long time to interactively extract insight from this particular visualization. It looks like the great pit of Carcoon from Return of the Jedi to me. It's fascinating as a visualization, yes, but it's not the kind of visualization that my brain's evolved to see patterns in. We instinctively understand how to look at objects spaced in 2 dimensions and figure out which are closer together and which aren't, and get meaning from that. And that means I can do something a little bit exotic, like a car switching matrix of a square table, which is what I'm doing now. Let's up those sample sizes, font sizes. And your brain can instinctively figure out how to read it. You look at Ford. Who are Ford's great competitors? GM and Rover. What's happening with Mercedes? It's very unique. Who does BMW compete with? All of these questions get much more quickly from this visualization, simply because we've evolved to read things like it. Here's some data on perceptions of supermarkets. Let's have a go at visualizing it. I'm again going to use an exotic technique, another form of correspondence analysis, and another one you've probably not seen before. And we'll again see our brain is remarkably good at figuring out the structure from the data. This visualization is about to appear as something called a moon plot. Now, while the visualization is by no means perfect, your brain instinctively looks at it and it tells you that Aldi is about low prices. It tells you that Aldi is kind of a bit on its own in terms of being a competitor in this market. It's not a perfect visualization. While we can see that Aldi is closer to low price than Costco, we can't really see by how much. So what's another type of visualization we could do for this data? Most market researchers with this type of data, their go-to visualization is to do a spider chart, a radar chart. And I heard another name for this the other day, I've forgotten it already. So let's do that and see what we get. So what's this visualization telling us? You can still see that Aldi owns low prices. So that's good. What else do you see? What shape do you see? I see this. Now, this is not the kind of shape that my brain's evolved to understand. These are actually the kind of shapes that my brain's evolved to understand. We instinctively compare shapes. And that's why pulling apart the radar chart and creating a whole lot of separate radar charts is actually a much better visualization. Your brain instinctively compares these shapes. It looks at it and it goes, but without even looking at the labels, it clearly tells you that this is a different shape to this. we can see that Aldi has got a very different positioning to Harris Farm, and we can see that all the different ones are different. Now, why is this working? The jargon for what I've done here is I've created small multiples. That is, multiple small visualizations, which our brains are just really good at understanding. Let's do another experiment to understand why our brains like smaller multiples, how it all works. Spot the odd one out. All right, spot the odd one out on this new one. And what's the odd one out here? I actually have to highlight the odd one out in the last one because quite a lot of people, when I presented this live, have gone, oh, I can't see. Why is the one on the right so much harder? Well, in the one on the left, we've encoded information into 3 visual dimensions. There's a horizontal position, there's a vertical position, and there's the color. In the one in the middle, we've again gone with horizontal and vertical position and the rotation of the line. In the one on the right, we've got horizontal, vertical position, color, and rotation. And just that 4th dimension forces our brain to have to work so much harder to decode the meaning, and that slows us down. So the point here is we want to use as few visual dimensions as we can. When designing visualizations, we need to make the patterns in the data really hard to miss. So if we're going to try and minimize the dimensions, which should we use? Should we use color, space, so on? Another experiment. Here I've encoded data into 4 graphical dimensions: horizontal position, the vertical position, the shading, and the rotation. What's the pattern? There's a correlation here, can you see it? Just in case you didn't spot it, the darker shades are more horizontal. The pattern is a perfect correlation. It's encoded in only 2 dimensions, shape and rotation, but our brain couldn't easily spot it. What's the pattern here? Yeah, this one is easier to see. The higher the vertical position, the darker the shading. What makes this one easier? The previous one encoded information in rotation, and we can process that information, but it was actually hard. Here we replace rotation with vertical position, and our brains found it a lot easier to spot the correlation between shading and the vertical position. Why is that? Well, it's actually because the vertical position is something we're great at. We've evolved to understand the concept of height. That's why column charts are so good. And now we've got a pattern that cannot be missed. There's a perfect correlation between the horizontal and vertical position. The shading is irrelevant, the rotation is irrelevant. It's an unmissable pattern because the key pattern is communicated by horizontal and vertical coordinates. Each of these visualizations shows a single perfect correlation. Each time it's encoded in only 2 graphical dimensions, but the one on the right is by far the easiest for our brains to spot because the key information is just shown in horizontal and vertical position. And this experiment's not an accident. Our brains are awesome at decoding information in horizontal and vertical space, so you should strive to create visualizations where the key patterns are encoded that way. Let's do another example. Here I've got some data on TV trends. How should we plot it? Jumping back to our instincts, we get lines and areas, which is line and area charts work so well. We've evolved to understand the size of hills and the slope of hills. So it taps into our skills. But as we'll see, not all line and area charts are great. Now, since market research was invented, the line chart has been the go-to way of visualizing time series. So let's use it to visualize our TV trends data. All right, what can you see here? Yeah, it's a mess. If you've got amazing color perception, you can probably work out that Game of Thrones is actually this big one that's spiking the most. But that's about it. The underlying data here is mutually exclusive, so we can actually improve this visualization by doing this as a stacked area chart, another popular one in the world of market research. So what can you see here? Just give a sec to update. Yeah, Game of Thrones has some big spikes. It's the easiest one to see because it happens to be on the bottom. And The Walking Dead in this brown, it seems to be fairly constant in terms of its popularity in the data. But it's still not a great visualization. Let's do something different. Stream graphs are great eye candy. And they're also quite clever. Looking here, we can see stuff that wasn't obvious before. In the middle, I can see Stranger Things now coming up as a brand. It's not a brand, there's a TV show that spikes at similar times to Walking Dead and also to Game of Thrones. Key thing about this visualization is it's symmetrical around the horizontal axis. And it turns out that's actually a general principle of visualization. When you make things symmetrical, it tends to free up kind of cognitive space to see patterns. But we're going to do something even better. We're going to return to the area chart. And just like before, we're going to do it as small multiples. Let's make it a little darker. Now, this is nowhere near as cool as the stream graph, but it's actually a vastly more useful visualization. It's just so easy to read. You can easily understand any one of the TV shows on its own and see what happened. You can easily overlay when the spikes are happening, get a feeling for kind of any commonalities in the market. And it's all because it's been pushed into 2 dimensions. The color has really got no role here other than a bit of glitz. Okay, so I've hopefully persuaded you that small multiples are a bit of magic. What's another technique we should use? We can encode the same pattern into visualizations multiple times. That is to perform what's called redundant encoding. Let's start with a small example involving average consumption of different brands of cola. Now, most people would show this as a bar chart, and so we'll do the same. Like most bar charts, a challenge with this one is that we have to read down to the axes to figure out what the values mean. This is why most market researchers tend to go and put the data labels on it. Now we can improve this one by sorting. Sorting is a great technique for all market research. Underdone? I'm sure you do sorting regularly. Let's sort this one. Now, there's something else that's interesting about this data when we're trying to visualize it, and that is that all the numbers are in the range of 0 to 7. Why is that interesting? Well, we're instinctively good at counting things, but only small numbers of things, and we can tap into that by changing this to a pictograph. Click the wrong option there. I can do better. Now, that's much better, but why is it showing men in this world? I'm going to show beverages instead. Got a beer icon I can use here, which will do the job. We could also put a custom icon if we wanted. Now note that the color here is purely uninformative. It's just a distraction. It's an irrelevant encoding that slows the brain down. So let's change it for something else. Note that Pepsi Light down here and Pepsi are different shades, even though they've got the same numbers. That doesn't quite make sense. So what we need to do is, at the moment, the coloring is just based on the ordering of the series. It's better if we actually hook it up and shade each individual value based on the actual data itself. And I might change the color palette as well here, I think, actually. I'm going to do something a little more custom. It's too custom. And I'm going to do it on the shade where we'll put low values. We do it a red color, kind of Coca-Cola-y kind of color. It's thin, and then high values dark, like a more full glass. Okay, so in this example, we have a simple little table of data, but I've encoded it into the visualization in 6 different ways. The numbers at the end show the information. The width of these bars show the information. The area of each of these shows information. The countable, or the little glasses themselves, allow me to again see the pattern in the data. The ordering shows the pattern in the data, and the intensity of the shading shows the pattern in the data. One pattern shown in 6 different ways. It's extremely hard for a user to miss the point. Let's do a more challenging example. Here's a type of problem we're all familiar with. I've got some spontaneous awareness data, but it's led to this massive table that's just too big to even fit on a page. How am I going to visualize it? Well, because we're good at instinctively understanding height, column charts are often the go-to chart. They're the ones our brain's probably best at decoding. Now, this definitely improves upon the table. We can at least see all of the information, but it's not a great visualization at all. It's just too hard. Maybe we could show it as bar chart. Let's try that. And it's still not good. Very easy to see. This is the biggest brand. Not so easy to read the label. There's no room. It's very easy to look at this and figure out how much of the cake has been eaten. No matter how many people say, gosh, pie charts and donut charts are rubbish, they actually tap into an instinct that we've got. We're really good at understanding them. And the problem is usually that they're badly created. Let's try and create a good one. Now, this one here, it'll take a second to appear. It's still not great, but note that at least we can see all of the labels for the bigger brands. What should we do next? And you know the answer to this, we're just going to sort it. Sorting the data can fix a lot of ills in a visualization. Now we've got, or you'll soon have, a much better visualization. The thing to note here again though is the color is just a distraction. We can make it better by reducing the variation. Like we did before, I'm going to change it to a gradient. But let's say that T-Mobile was our client. How can we make this an even better visualization? I'm actually going to remove a lot of color. So while we've got a redundant encoding here, it's often sensible to remove color. I'm going to do it by choosing custom palette, which allows me to type everything in little codes. So I'm just paste in some that I've already copied just before. I'm just going to make everything gray. Now, T-Mobile has actually got its own trademark pink. Let's see what happens when we change that. We'll change the third one, which is T-Mobile. And ta-da, we're got a visualization now which very clearly shows where T-Mobile fits in terms of the top of mind spontaneous awareness data. So we've just looked at reducing color and emphasizing as techniques. Banking to 45 degrees is one of my favorite techniques. A case study, not market research data, I'm afraid, but just too beautiful not to show. Dark spots appear on the sun and they're cleverly known as sunspots. They can last for a few days or a few months. This data set tracks the number of sunspots monthly over 250 years. It's got more than 3,000 data points. Let's plot them as an area chart. So when it appears, I want you to ask yourself, what can you see? Try and spot the pattern. So the first thing that you can see is it seems to jump up in these little oscillations. And if you do your math quickly in your head, it seems that each one takes about 11 years on average. The second thing is there's some kind of bigger pattern oscillation, up, down, going on in the data. But now for the magic. Right, so I've just shrunk it. It should be harder, shouldn't it? But what can you see? Squint, it's worth it. There's a little pattern that's now become clear, which is that the sunspots peak up, go slowly down, peak up, go slowly down, peak up, go slowly down. It's a very common pattern. It turns out that if we change the height and the width so that the average of the data we want to examine in a visualization is at about 45 degrees, we create visualizations that are just much easier for our brains to process. There's no need to be mathematical, just use your eye resizing things. Here's an example looking at some political data. Which is the better visualization? Yeah, it's clearly the one on the right. In it, I've done 4 things. The data has been banked to 45 degrees, as just discussed. I've also used a lot of gray, as we talked about. I've emphasized the key pattern that I'm interested in. And I've got rid of these things here, put them at the end of the labels just to reduce the amount of effort our brain has to put into looking things up. But back to banking. Why does banking work? Here's my theory. I want you to lean back. What can you see? Now I want you to lean in, all the way in, so your nose is touching your screen. What do you see? That's right, there's a gremlin. Well, to the right, there's a toucan with a really big claw. For optimal viewing, we want an image to be in an angle from our eyes of about 4 to 6 degrees from our retina. This means that if we're viewing from about 20 inches or 50 centimeters away, our ideal image is only about 2 inches or 5 centimeters high. And this explains a bit why banking works. We are wanting key features of the data to be visible in a small area, an area of about 2 inches by 2 inches. And if we resize things that are 45 degrees to kind of the 45-degree slope that I was talking about with banking, it actually turns out to most efficiently do this, if you remember your Pythagoras from school. It also helps us to understand why small multiples work, because each of the visualizations is around the optimal viewing size. Now, this is my all-time favorite technique. I even wrote the Wikipedia page on it. It's called diagonalization. And the basic idea is that you rearrange the rows and the columns of tables, charts, and small multiples so that patterns appear, typically diagonal patterns. This is my all-time favorite visualization. Each of these little area charts shows the size of an economy. We've got data going all the way back from 2000 BC through to 1804. I'll just point out a few things. At the very top, we can see the USA, and it's got this big dip, which is showing the effect that the War of Independence had on the economy. Note small multiples again. Note that each of the curves is kind of banked to the extent it can be, so we've got a clearly visible bump that we can identify. Now, the genius who made this has ordered the economies so that their bumps make a diagonal line. Now, the diagonal line isn't straight, and this in itself emphasizes something very profound. There are no real bumps between the birth of Christ, or just after the birth of Christ, and the Renaissance. In this middle area, only Constantinople thrives, and that's why it's called the Dark Ages. And this visualization draws it starkly, quickly to our attention. But back to market research data. This is a really big table. It's not immediately obvious to you how big it is until you notice the scroll bar. Dun, 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 dun. Much too big for our little brains. What are we going to do? Standard way to visualize a really big table is to start with a heat map. Let's get those font sizes up a bit small to read, isn't it? While we're doing that, see what you can figure out from it. What patterns can you see? Now, it's very hard to see a pattern. It actually looks like bathroom tiles that I had in a bathroom many, many years ago. So we want to, as I've mentioned, diagonalize. We want to change the rows and the columns so that a diagonal line appears in the data. Fortunately, we've got a nice shortcut way of doing this. I'm just going to choose this little option to sort all the columns by pattern. And then I'm going to get to sort all the rows by pattern. And now, once it updates on your screen, you will see that we do have a kind of diagonal pattern automatically. Top left, dark blue, diagonal, bottom right, dark blue. So what can you see here? Note at the bottom right, we can see we've got Coca-Cola and Pepsi, and they've been grouped together. And they've got darker shades, and we can see that what they've got in common is they're kind of more on this masculine, older, traditional dimension. So we're again much more easily seeing the pattern. In the top left, it's grouped together Diet Pepsi, Diet Coke, Coke Zero, and Pepsi Max, all the sugar-free brands. And we can see that they share these health-conscious and weight-conscious dimensions. But it also draws to our attention that Diet Pepsi and Diet Coke have got this feminine, innocent, whereas Coke Zero and Pepsi Max we can see are about being unconventional, trying to be cool, open to new experiences, sexy, and so on. So we're much more quickly able to see the pattern in the underlying data just due to having formed a diagonal image in the visualization. Here's our earlier small multiples of radar charts. I've ordered these again to make the patterns a bit easier to see. And to further emphasize this, I've plotted averages on. Note that we can see on the left, Woolworths and Coles are basically the same shape. But due to having the average, we can even see that actually Coles is better in terms of low prices than Woolworths. All the other brands we can see are pretty weak on multiple things. They're all inside that little grey shape. This visualization is awesome. It's not particularly pretty, but it's truly awesome. Here, the small multiples have been arranged to make these wonderful wave patterns. And it's not just an aesthetic trick. Our brains can use that information, that contextual information, to figure stuff out. So if I say to you, which industries had the biggest drop then increase? Yeah, you very quickly go, all right, we're talking IT and financial services. You can just, your brain instantly works all out because the effort's been taken to rearrange the visualizations to make a pattern, type of pattern our brains understand, which allow us to pick out exceptions to it and find interesting features. So we've covered most of the 24 techniques here. And if you want more information, there's a book. You can download it for free on our website, of course. Or if you want to put 10 cents towards my retirement, you can go and buy it on Amazon. Now, if you have any questions, please type them into the GoToWebinar application and little questions box, and I'll get onto them. So the first question from Kerry is, are you going to show examples of how to make them in Displayr or just show examples? Well, hopefully you've seen lots of examples of showing them there. Second question is, can I do all of this in Excel? Look, you can do it in Excel, but the challenge you get to when you use Excel for things like this, and it's just got a simple thing that's missing, is that it doesn't really have small multiples, and it's got no way of doing them other than to manually create them one by one, and then you spend a lot of time lining them up, which gets very, very painful. I think small multiples are pretty important, so you're probably better off using some slightly more modern software than that. The next question we've got is, should visualizations be interactive or static? Well, it depends on your audience. So if it's a dashboard, you want them interactive. And when they're interactive, you don't have to put labels on. But obviously, PowerPoint, not much point having them interactive because PowerPoint's not interactive. And that's all the questions we've got. Look, thank you very much for attending this webinar. And for all of you who are our clients out there, thank you for being our clients. Bye now.